All right, in 2.5, we're going to go through the product and quotient rule. Up until now, these are new derivative rules. Up until now, the rules we've learned have been for specific functions. Like we have the power rule, like x to a power, you drop the power down, subtract 1. We have the cosine rule for taking the derivative of cosine, sine, e to the x, and the ln of x. These two rules, a product and quotient rule, aren't for specific functions. They're for cases when you have two functions either multiplied together or you have them divided. They're set up as a fraction. So in those cases, we can use these two rules to find their derivatives. So here are the rules. Start with the product rule. If I have the derivative of f of x times g of x, I take the derivative equals, I take the first times the derivative of the second, plus the second times the derivative of the first. That's what they're saying over here, right? F stands for first, S stands for second. So, right, first times the derivative of the second, plus the second times the derivative of the first. The quotient rule, if you have two things that are divided, usually set up as a fraction like this. So I have f of x divided by g of x. This is our quotient rules. I take the bottom function, g of x, times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom 1 squared. So again, this is the same rule, just written a different way, right? Top, bottom, bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom squared. Okay, that gives us the quotient rule. Let me show you some examples. So here's this first one. I have f of x equals 3x squared minus 2 times 2x plus 3. So make sure you identify what's being multiplied together. I have 3x squared minus 2 and 2x plus 3. So this is my first function. This is my second function. So here's what the rule says. If I'm finding the derivative, f prime of x, I take the first 3x squared minus 2 times the derivative of the second. The derivative of 2x is 2 when the 3 goes away, so it's just 2. Plus the first one, or the second one, excuse me, 2x plus 3 times the derivative of the first one. The derivative of 3x squared is 6x squared. Not 6x squared, sorry, just 6x. Sorry about that. Okay, go ahead and multiply this through. Right? I got the first times the derivative of the second, plus the second times the derivative of the first. So multiply that through. It comes out to be 6x squared minus 4 plus 12x squared plus 18x. Okay, let's do some simplifying here. So f prime of x is going to equal, I've got 6x squared plus 12x squared, that's 18x squared, plus 18x minus 4. If you look back at that problem, I hope some of us recognized or saw, we actually did problems like this before without using the product rule. And the way we did it is we multiplied it out first, and then we did it term by term using the power rule. So let's look at that other way, and we'll just show that you get the same thing. So if I multiply it out, right, I'm going to put that up over here. F of x equals, let's multiply it out. This would be 6x cubed plus 9x squared minus 4x minus 6. Okay, that's what the derivative, that's what f of x comes out to be if I just multiply it out. Well, now I can just do it term by term like we have before, right? These are all just the power rule. So let's take the derivative, f prime of x. The 3 drops down, so 3 times 6 is 18, subtract 1 from the power. The 2 drops down, subtract 1 from the power. Minus 4x just becomes minus 4, and the minus 6 goes away. Hey, I got the exact same thing, right? It worked out to be the same thing. So there are some cases where you can choose. If you can multiply it out and simplify it and then just do it term by term, you can do it that way. That's the way we've already done it. And I really think a lot of times that's the easiest way. Or you can use this new product rule that we just learned. Sometimes, though, we don't have a choice. I want to look at number 4 real quick. So if you guys will go down to number 4. So I have g of x equals 3 e to the x times sine of x. I have two separate functions that are multiplied together. I have 3e to the x, and I have the sine of x. There is no way to simplify that, right? I can't multiply that out and do it term by term. So on that problem, I have to do the product rule. I don't have a choice, like number 1. So let's go ahead and do that. Let's just do number 4, then we'll go back and we'll do the quotient rules. So if I have, I'm going to find g prime of x. So I take the first function, 3e to the x, times the derivative of the second. Well, the derivative of the sine function is the cosine function. Plus, I take the second function, sine of x, times by the derivative of the first. Well, the derivative of 3e to the x, the 3 stays there, and the derivative of the x is still e to the x. And I'm done. That's my answer. I can't add those because they're not like terms. There's nothing really to do with those, so we're just finished. So again, that's an example where my two functions, I could not multiply it out and simplify it first, so I had to know the product rule. This one up here, I had a choice. I could use the product rule using my two functions, or I could multiply it out first. I'm sorry about that, and then find the derivative afterwards. Okay, hey, let's look at number 2. So number 2, we could try simplifying that so that I could do it term by term. But the problem is with that 2 minus 3x in the denominator, that makes it really difficult. To simplify that, you'd have to do long division, and it just gets messy and we don't want to. So instead, we're going to use the quotient rule. Make sure, I know it doesn't show the quotient rule on this page, make sure you have it in front of you, right there in your book, and watch as we go through here. So this would be my top function, 2x squared minus 4x plus 3, and this is my bottom function, 2 minus 3x. Okay, so what the quotient rule says is y prime, my derivative, equals the bottom, 2 minus 3x, times the derivative of the top. So I take the derivative of the 2x squared minus 4x. That would be 4x minus 4. Minus, I did not leave myself enough room. Let me slide this over here for a moment. We'll slide this whole thing over, and that way we'll have enough room to show this. Okay, so I had the bottom times the derivative of the top, right? Bottom times the derivative of the top, minus, now I take the top times the derivative of the bottom. The top is 2x squared minus 4x plus 3 times the derivative of the bottom. The bottom, derivative of that is a minus 3. All over the bottom squared. The bottom is 2 minus 3x squared. Okay, we get to there. We could try simplifying this if we wanted to. That top, we could probably simplify down. One thing to point out, one thing not to do, is do not cancel out that 2 minus 3x and that 2 minus 3x, right? If you want to cancel out that 2 minus 3x, we have to have a 2 minus 3x over there also, which we don't. So let's multiply out the top real fast just to see what it comes out to. So that would be 8x minus 8 minus 12x plus 12x. Oh, that should be minus 12x squared plus 12x minus 6x squared plus 12x minus 9 all over my denominator right there, right? I'm just being lazy and don't want to write that again. Okay, so let's go ahead and combine like terms. I have a minus 12x squared minus 6x squared. That'd be minus 18x squared. I've got what? 12x and a 12x is 24x. Oh, I got another 8x over here also, actually, right? So I've got 12x plus 12x plus 8x. So that would actually be 32x. And I got minus 8 minus 9 all over 2 minus 3x squared. And I can't really do much of that. You could try factoring that top part, but it doesn't factor. So that is my derivative. So it could get kind of long and messy. Like there's a lot to these. But it does give us a way, like I don't have any other way of doing this. There's no way to simplify this. So without the quotient rule, I wouldn't be able to take the derivative at all. So I can do that now. Okay, let's do that example number 3. Okay, so 3, we could actually do it either way. We could do it the way we did it before, or we could do it with the quotient rule. I'm going to do it with the quotient rule first, since that's what we're practicing. Then I'll go back and show you that other way. So the quotient rule, right, I take the bottom, which is 5x squared, and I times it by the derivative of the top. Well, the derivative of negative 9 is just 0, minus the top, negative 9 times the derivative of the bottom. Well, the derivative of 5x squared is 10x. And that's all over the bottom squared. So that would be 5x squared squared. Okay, let's do some simplifying. Up on top, 0 times 5x squared. That part just comes out to be 0. I have a minus 10x times negative 9. That'd be a positive 90x. On the bottom, if I square 5, 25, I square the x squared, x to the 4th. So, well, I almost made a mistake here. Be really careful with this. This does not equal this, right? I'm going to slide that up. This is what y primed equals. Ooh, be careful with that. Okay, let's simplify that. 90 over 25, you can divide them both by 5. 5 goes into 90, I think, 18 times. 25, it goes into it 5 times. X over x to the 4th, you can cancel out one of those x's. So we get 18 over 5x to the 3rd. Okay, that's one way you can do it. That's using the quotient rule. The way we've done it before is we've taken this and we've moved it up to the top. So we wrote y as being negative 9/5 x to the negative 2. Okay, negative 2 drops down, so I have negative 9/5. This is y prime. I have negative 9/5 times negative 2 times x to the negative 3. Well, when I times these, right, that's over 1. That ends up being 18 over 5. And then x to the negative 3. Hey, that's the same thing as I got down here, right? I can move that x to the negative 3 to the bottom and I get the answer. This way seems a lot easier to me, right? So a lot of times you can use those old ways we manipulated them algebraically to get them in a form that we can use the power rule or that we can go term by term. And it ends up being a little quicker and easier than using the quotient rule. So if you can do that, feel free to. In fact, part of the assignment will be just practicing recognizing when. So here's the assignment. Right, the first one says use a product rule. So this one it tells you to, and then it tells you to do the same problem down here without using the product rule. So down here you're going to multiply it out first, find the answer, and then take the derivative. This one down here says, right, use the quotient rule. This one says differentiate without using the quotient rule. Like on this one, we've done these before. We try to simplify it. The top becomes x plus 2. You can cancel out the x plus 2. And now it's really simple because I just take the derivative of x minus 2. So really quick and easy. So you're going to practice both. Don't forget all the other stuff we've done. On this one, it says use the method you wish. Hey, I would just say, like in number 5, it's really easy to divide both of those by 4. You can rewrite this as being 3x squared minus 1. And you can take the derivative of that in your head just in seconds. That's a lot easier than using the quotient rule. Same thing here. You could times through by 1 over t squared. That would get you t cubed over t squared, which is t, and t squared over t squared, which is 1. That's really easy to find the derivative of, a lot easier than trying to do the product rule. Same thing with 7. If you just times through by 2, then you can take the derivative. Now when you get to number 8, there's no way to break this one apart. That doesn't work without doing long division, which is kind of messy. So on that one, I just do the quotient rule. Hey, number 9, this is really easy to do if you multiply it out first. That's x to the 1/2 times x plus 1. You can just distribute, add those powers, distribute, and then take the derivative afterwards. On number 10, there is no way to simplify this. You've got to use the quotient rule. I cannot simplify cosine of x over x cubed. Number 11, I would just times through by 2. And then I don't think there's any way to simplify the quotient. So you'll have to do the quotient rule after that. Number 12, again, use the quotient rule on that. You'll see how that works out. So you got to kind of decide in there. Don't forget all the other stuff we've done. There's ways to simplify functions first so that you don't have to use the product or quotient rule because they can get kind of long. There's a lot to them. It just takes a little bit of practice and it takes recognizing as you go through there. Make sure you're asking me questions if you have them. There's problems you're not sure about. But these are 2 rules we'll use a lot. We're going to use these throughout the year. All right, thanks, guys.